sir.
Good morning. How are you? Have a seat.
Thank you.
Okay. Today I want to discuss different questions from the Nectas. Okay?
Yes.
Now I have a few questions from examination, Necta examination 2020. Okay?
Yes.
Okay. Now prepare in order to discuss these questions. Okay?
Yes.
I choose the question from current electricity, but this is question number 10 in section B. But question number 10, B. Okay?
Yes.
20, the examination 2020. Okay?
Yes.
Let me read the question. Okay? The figure 4 shows an electrical circuit. Carefully study it and calculate the value of current X and the resistance what R. Have you seen the circuit?
Yes.
Okay. Now here our circuit shows there is a symbol of EMF. Okay.
Yes.
But also the circuit shows there is a total current which is 5.2 ampere. Okay?
Yes.
But you see there are two junctions and there are two resistors which are connected in parallel. Okay?
Yes.
You have resistor R which is unknown, but you have resistor which have the resistance of 4 ohms. Okay?
Yes.
Now our work is to find the current which is labeled as letter X. Okay?
Yes.
To find the current labeled as what? X. Also to find the resistance labeled as what? As R. Okay?
Yes.
Now I want to show you how to solve this what question. How to answer this what?
Question.
The first one is to look carefully the what? The circuit. Okay?
Yes.
Have you looked it careful?
Yes.
Yes. So it shows that we have total current, okay,
Yes.
which is 5 ampere, but also we have the current to the junction, which is the current labeled 3.2 ampere, okay?
Yes.
This current 3.2 ampere passed through the resistor labeled as 4 ohm watt, 4 ohms, okay?
Yes.
But you have also the current passing through the junction, whereby this current is labeled as XC, but is passing to the resistance labeled as R watt ohms. Okay?
Yes.
Now the following is the solution. Now from the figure, the total current, as you say, it is 5.2 ampere. Okay?
Yes.
Now then, at the junction, if you want to find the total current, you say that you take the current to the junction labeled as XC, then you plus the current labeled as 3.2. This gives the sum of what? Of the current. Now if you want to find the value of XC, means that you take 5.2 minus 3.2 what? Ampere. Then you have already get the unknown current labeled as XC, which is 2.0 what? Ampere. It is clear?
Yes.
Oh, good. Now we are going to find the resistance labeled as what? X. But we have two resistors. The resistance or the resistor labeled as 4 ohms and the resistor labeled as out ohms. Okay?
Yes.
But we know that the resistors which are connected in parallel, what is about the potential difference?
Yes.
The potential difference is what?
The same.
Is the same. Okay?
Yes.
Now, if it is the same, let us find the potential difference passing through the resistor labeled as 4 ohm watt resistor. Because the current is given, it is 3 point what? Okay?
Yes.
Now, how to find what we say that how to find the resistor, we say that how to find the potential difference. Okay?
Yes.
In order to find the potential difference, we know that from Ohm's law, then V is equal to I. So we substitute the value of I, which is 3.2, okay?
Yes.
Times the value of R, which is 4.0 ohms, okay?
Yes.
Then we find the potential what? Potential difference, okay?
Yes.
And the potential difference from the calculation is 12 point what? 8.8, okay?
Yes.
Now from that, we start to find the value of unknown what? Resistor labeled as what? As R. Okay? Because potential difference is the same, okay?
Yes.
Then you can find what? This resistor labeled as what? As R from Ohm's law, V is equal to I R. Because we are finding the resistor R, okay?
Yes.
Resistor R is the resistance of the resistor R, okay?
Yes.
From the figure, this one. You see, this one here. Okay?
Yes.
I want to find the resistance of the resistor labeled as what? As R. And we know that this resistor is parallel to the resistor labeled with the resistance of 4 ohms. And we know that if the resistors are connected in parallel, the potential difference is what?
It's the same.
Okay?
Yes.
Now we have already calculated the potential difference, okay?
Yes.
Which is 12.8. So in order to find the resistor R from Ohm's law, also we substitute to our formula V is equal to IR, okay?
Yes.
Then we make R the subject, then we substitute the value of what? The value of current and the value of what? Of what? Voltage or potential difference. Then from that we get the value of R from the calculation. Do you have a calculator?
Yes.
Can you find it? Then you get the value of R is 6.4 ohms. So from that, our question is what? Is done. We have already calculated the value of unknown current X, which is 2.0. Have you seen it? This one. Okay?
Yes.
This one. The value of current labeled as X is 2.0 what? Ampere. Also, we have already calculated the value of resistance labeled as X as R is 6.4. So this is the end of the solution of this question. Okay?
Yes.
Now let us see another question. We have another question. From that question, section C said that from part A or from part B now, because this is 10B, okay? From part B, then from part B, C, the question 10C said that from part B, determine the effective what? Resistance. Effective what? Resistance. And when we talk about effective resistance, we mean that we determine the total what? The total resistance. When these two resistors are connected what? In parallel. Okay?
Yes.
Okay, let's see the solution. Now we know that the effective resistance, we say that this is the total resistance when these two resistors are connected what? In parallel. Now we have two resistors. The one is labeled, it has 2.0 what? Ohms. And the other is, we say that the other is, sorry. we have the resistors. The one is labeled as 4 ohms, okay?
Yes.
And the others is the one calculated as R, okay? Which is okay, we have already calculated, which is 6.4 watts. Yeah, and we know that from the formula for the resistance which are connected in parallel, we say that 1 of R total is equal to 1 over R1 plus 1 over R2. Okay? Now if you make R total, it seems that R1 times R2 then divided by R1 plus what? R2. Are we together?
Yes.
Then we substitute here the data. Okay? You see 6.0 ohms times 4.0 ohms, then divide by 6.0 ohms, then plus 4.0 ohms. Okay? Yes. Then 6.0 times 4, then you get 25.6. Then divide by 6 plus 4, then 6.4 plus 4, then you get 10.4. Now if we divide, you get the total resistance or the effective resistance R is equal to 2.462 ohms. And it seems that for the resistors which are connected in parallel, so the resistance what? Decreases. Okay? Yes. Compared to the resistance which are connected what? In series. Okay? Yes. Thank you. Now this is the end of my presentation.